Hello, good morning, SH2 students. Yes, this is the last day of school, and also this is the last day for you as a SH2 students. Okay, it's quite sad because you need to end this SH2 with these kind of conditions, but I hope that you still have the spirit for studying, especially for the next level, and I make sure that I will meet you again in SH3. Then we will have fun again. Okay, so for last day, I still need you guys to finish the end of chapter questions of chapter 31. So yesterday we have done until number 10 because number 11 is mostly theory. So we just keep it, it's okay. Let's continue to number 12. This question is about the nucleus of uranium-235, which has mass of 3.89 times 10 to the power of negative 25 kilogram. State the number of protons and neutrons in the nucleus. And then if they give you the radius of the nucleus is 1.41 times 10 to the power of negative 15, A to the power of 1 over 3, where A is the nuclear number of the nucleus, determine the density of the nucleus. And then explain why the total mass of the nucleus is different from the mass of uranium-235 nucleus. And then D, without calculations, explain how you can determine the binding energy per nucleon for the uranium-235 nucleus from its mass and the masses of a proton and a neutron. So this is how to do number 12. For 12A, it's very easy. You just need to count the number of protons and neutrons by minusing the mass number and the nucleus number. And for 12B, you need to find the volume of the atom first by put into the formula of the volume of a sphere. 4 over 3 pi r to the power of 3, pi r cubed. So find the radius from this formula. And then for 12C, the question just now is explain why the total mass of the nucleus is different from the mass of the uranium-235 nucleus. Oh, sorry, for number 12B, after you find the volume, yes, after you find the volume, then you need to find the density because you know the mass, right? You know that rule or density is mass over volume. Okay, so find it from that equations. For the answer 12C, you just need to continue this sentence that I've made. When the nucleons combines, they will have what? Okay. To explain why the total mass of the nucleus is different from the mass. And for D, without calculations, explain how you can determine the binding energy per nucleon for the uranium-235. It's easy because you can use delta E equal to mc square here, of course. But before you use this formula, what things that you should know first? Now explain it first, and then after that you mention after knowing this, then we can use the delta E equal to mc squared. Okay, so add 2 more sentences before the use of delta E equal to mc squared. Okay, I hope it's quite clear for number 12, and then after that, let's go to number 13. Explain what is meant by nuclear fusion and explain why it only occurs at a very high temperatures. This one you can see the answer from your textbook. Yes, okay, and then for 13B, the main reactions which fuel the sun are the fusions of hydrogen nuclides to form helium nuclides. However, other reactions do occur in one such reaction known as the triple alpha process. Three helium nuclei collide and fuse to form a carbon-12 nucleus. 13b.1 explain why temperatures higher than those required for those fusion of hydrogen are needed for the triple alpha process. Okay, for 13b, because it is also theory, you can check it also from your textbook. And for 13b, the main reactions 13b.2 calculate the inner energy release in the triple alpha process. If we know that mass of helium, helium-4 is 4.001506 U and mass of carbon-12 is 12 U. 1 U is equal to 1.66 times 10 to the power of negative 27. Okay, so to count this, we need to find the mass difference first. Yeah, the mass difference. It means after the reaction minus before the reaction. Then you will find it in the form of U. After you find it in the form of U, then change it into kilogram. After you find the mass in kilogram, then you just simply put into the formula delta E equal to mc square, while m is from here, and then c is the speed of light. Don't forget to square it. And yes, that's it for number 13. Next is the last number. Or you have your holiday. Sorry, star. So for number 14, oh, okay, this one. Number 14. The radioactive isotope of polonium 218 decays by the emissions of an alpha particle with half-life of 183 seconds. In an accident, at a reposing plant, some of this isotope in the form of dust is released into the atmosphere. Explain why spillage in the form of a dust is very much dangerous to health than liquid spillage. So the answer for this one, I give you a clue. Just fill in this blank. Alpha particles have blah 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 penetrations. Is it low or high penetrations mentioned? So explain what will happen if it is have high penetration or low penetrations. While dust can be inhaled and get into our body, and what will happen? Okay, so just follow the sentence, fill in the blank. Number 14b. It is calculated that 2.4 gram of this isotope is released into the atmosphere. Calculate the initial activity of the released polonium. So here we can use the formula N equal to 2.4 over 218 times Na. Why 218 times Na? Because there are 218 nucleons in this polonium. Okay, times the Avogadro constant. Okay, times the Avogadro constant. And one. And yes, after that, you can find n. After you find n, you can find lambda. Lambda is equal to logarithm natural 2 over 183. This one is the half-life, the time taken, right? And after you find lambda, then you can find the activity. Activity is lambda times n. So the lambda from here times with the number of undecayed nucleus. And for Next question C. It is felt that it would be safe to re-enter the laboratory with the activity falls to background, about 10 becquerels. Calculate how many hours must pass before it is safe to re-enter the laboratory. So for this one, C, we know the formula lambda times t equal to logarithm natural activity, the original activity over the activity itself. And you just need to put in, we got the activity from here, this one, 2.5 times 10 to the power of negative 19. And then after that, you divide by the activity which is safe. Just now, they say 10 becquerels, right? Then you divide. And then after that, you calculate the logarithm natural. And you will find the time which is safe for us already to re-enter the scaled room. Okay, guys. Yes, that's it for today. And yes, you need to submit it to me before 4 p.m. like usual. I will check it. And then I hope within these 2 weeks, within these holidays, you can do many positive things, okay? Keep social distancing and stay safe at home. See you again next 2 weeks. The same lesson, physics, with a new spirit, of course. I want it from you. And yes, thank you for this 1 year listening to me. And if I have, let's say, any mistakes, then ask your forgiveness for that one. Okay, and I forgive you, of course. Okay, guys, that's all for today. See you again in SH3. Thank you very much. Bye bye.